So just a heads up, 3.4 is on the quiz. I did that wrong. So today is just a homework day to see, did you understand the homework yesterday, and to review anything you want for the quiz. And from the homework, this one is a very good graph to be like, hey, can you tell what's going on? So the story of this, the rocket, whoosh, burns through the propellant, coasts for a while, starts to fall, parachute comes out, and the sound effects make it more fun, Ben. Yeah. So, where does the propellant burn out? What time? Show you.
2 seconds.
In about 2 seconds. So, right here. Is that when it starts falling?
No.
No. Tim, when does it start falling?
8 seconds.
At 8 seconds. Okay, part of the stuff on the test, justify that. What do I want as justification? Does anybody have an answer now?
Switch is
What?
Switch is side.
What switches sign?
Velocity.
Okay. And I'm fine with because being B/C. It changes direction because the velocity switches sign. Do not use pronouns. Note it. Note the function, because now that we've done some derivatives, if I give you position and you say the function, are you referring to position function, or its derivative velocity, or its derivative of that acceleration? Yahia, you were going to say something?
Not the slope switches signs, not velocity.
Well, if I gave you a position graph, it would be that the slope changed sign. Like, so you got to be clear to me. What are you talking about? Are you talking about the slope of velocity? What is the slope of velocity? Acceleration. So if you just say the slope, I don't know who you're talking about. So, and if you just say the function, are you talking about velocity or the derivative of velocity or the integral of velocity, which we haven't done yet? But be clear. And he said, velocity changes sign. Perfect. What happens right here? Does it start going up? No, it's still falling. Its velocity is still negative. It's still going down, but it's slowed down. Okay. When is it going fastest? When is it accelerating the most? Like right around here. That is also when it's going fastest, and it's accelerating fastest there because the velocity, or sorry, the slope of velocity is at its steepest. It's accelerating pretty quickly there as well, but this one is sharper. This was not a question that was in the problem, but let's say that rocket was launched from 100 feet in the air. Yeah, feet. Is the rocket above or below the launch point, equal to the launch point, or can we not tell? At the end of wherever that is. Can't tell? We can tell. How can we tell?
Well, because you have velocity, you can, and if you have the initial position, you can figure out position, as well as that the.
Well, I can integrate, but I don't know how to do that yet. With what I know now, but.
You can just sort of see, like, it spends a lot of time going upwards and not that much time going down, and it goes really fast upwards and not that fast down.
Okay, all right, cool. So it's like, it spends a long time going fast. So for 3 or 4 seconds, it's doing 100 feet per second or more. So that's gone 300 feet up, and then on the down, you know, even like over exaggerating, being like, well, maybe it was doing that 90 going down for 4 seconds. I didn't catch up. So it went up more than it went down. So it will be above the platform when it's been launched. Physics friends, those who know calculus already, what are you actually looking at? No?
The average velocity over a period of time.
Mm,
That's what I would do. For this one, it's very slow.
area under the curve. So the more stuff colored in, when we learn integration, which doesn't come till December, but all that stuff, that's kind of like distance accumulated in the upwards direction. And this stuff is distance accumulated going back down. The up is much bigger than the down. Okay. The kinds of things I want to make sure you can understand and read. First of all, this one, we were given a velocity graph, and this one is a position graph. Read the words carefully. Did I give you position or did I give you velocity? Because if you answer the questions about velocity, and it gave you a velocity graph, but you're thinking it was a position graph, you will get every single question wrong. All of them. And by the way, I won't give you position because it's just trivial. So this graph, velocity or position?
Velocity.
Velocity, okay. So Iman, given this graph of velocity, when does the thing change direction?
Second, 2 seconds and 7.
Okay? And,
10.
okay, 10 is the end point, I don't care. What's my reasoning? Why does he know that it changes direction there?
Velocity changes sign.
Thank you for no pronouns. Where does it change sign? 2 and 7. I just use pronouns. Where does velocity change sign is where this thing changes position, reverses direction. When is it moving at a constant speed? Looks like 3 to 6. And what would our reasoning be?
3 to 0. Put the slope is 0.
Okay, slope of velocity, so, all right,
Acceleration is 0.
It's not accelerating.
so, early for this, but AP, if I gave you a graph of velocity and you talked to me about acceleration, you need to tell me, how did you know that that was acceleration? So you could say, because the acceleration is 0, which, by the way, I read the acceleration by looking at the slope of velocity. So somehow you need to say, like, if you want to say acceleration is 0, but I gave you a graph of velocity, you need to tell me how you are reading acceleration from the velocity. Well, the slope of velocity is acceleration. It's not on this one, it's on a later one, but I'll ask it here. Where's the object speeding up? So, so 0 to 1, 2 to 3, anywhere? 7 to 8? 0 to 1, 2 to 3, 7 to 8. I agree. Can someone else tell me why? Yassine?
Because velocity is positive, or velocity and acceleration are the same sign.
So, because velocity and acceleration have the same sign, and I'm like, oh, by the way, if I didn't say it earlier, acceleration, well, like, that's the slope of velocity, cool. Okay. Position graph. When is the particle moving left? Asher, when is it moving left?
2 to 3, and 5 to 6.
And what are you looking at to see that?
Negative slope.
Moving left. So, when the position function has negative slope, the velocity is negative. When the velocity is negative, it's moving left. When is it moving to the right? When it has positive slope. But, sorry, no it's. When the position's slope is positive. Okay, doesn't fit. Okay. Are you guys okay with 25, which is more, when is it moving forward, when is it moving backward? And what is, so when is it, given this graph, when is the particle moving forward?
When it's positive.
When?
When x is positive.
When x-
Sorry, when y is positive, or velocity.
And so when is that?
Does it go by 1? I can't really read it.
Yeah.
It's from 0 to 1, and then from, is it 5 to 7? And then it's,
Then it's 0 for a bit. Yep. Okay, yep. Position, velocity, acceleration. Who's who? Jesse?
Position C, velocity A, acceleration B.
And how did you reason that?
Oh, I looked at it because A is the derivative of C and B is the derivative of A.
How do you know that?
Because the horizontal tangents of each function have a 0 at that x value of the next function.
Okay, so that guy's zeros, the horizontal tangents of C go to the roots for A, so I agree that those would be derivatives of each other. And then velocity is this parabola, its one and only horizontal tangent meets up with the 0 of that straight line, and some of you were like, well, looks like a cubic, goes to a quadratic, which goes to a linear. That works too. If you read email anytime today, I sent you an email that I created an optional delta math. And there is a set of questions you can do that are, hey, here are these 3 functions, match them. Oh my God, they're hard. Yeah. You have to fill out a pass. So, super, like, some of them are like, what? Like, one of them, by the way, there is a function that is its own grandpa, it is its own derivative. So, I don't know. It is its own grandpa, I don't know. But there are also derivatives stated like this, where I can be like, really checking that you know what's going on. We will try one of these, but I want you to do this one first. Do not create a piecewise function for F. I know, sorry, I reset. Let's do this.
Are you just-
Over to F prime of X, and then just resident layers. Give F prime of X times the derivative.
Where would you get it?
Yeah.
The slope is at F and negative 1 there. 2.9. That's the graph of F and X. Look at the slope at F and X.
When you plug in X for F prime of X, you get the slope. It's negative 1, right there.
Yeah, how do you find
You just do G prime of X, which is 2 times 2 times X. So 2 times 8, 16.
Yeah, so
Over negative 1, which is the slope of the graph is negative 1. No, I'm talking about G X.
I wrote F prime of X.
Look at whatever.
Well, I just put,
I just didn't simplify it. I just
yeah. I just didn't simplify f of x ever. I just kept f of x in there. But you could simplify g of x.
But you can simplify because you know what G prime of X is, so then you just write it as. Yeah, but then you see how
So-
I simplified it, so I have what she has written down.
I try to be more careful with this now, that I will ask, tell me h prime of x. It is in your best interest to show me this anyway, because those of you who go straight to numbers and bleep up one of the numbers, because you do like me and read the wrong thing from the chart or whatever, you get it all wrong. So you will be careful. Okay, so now that I have the alphabet soup, f of 8. Okay, here's my graph. What is f of 8? 2. When x is 8, the y value is 2. G prime of x. Okay. Michael, what's g prime of x?
2x.
2x. Wilkie, what is g prime of 8?
16.
16. Sam, what is g of 8?
13.
G of 8.
Oh, 61.
Yeah, weird number. So on f prime of 8.
-1,
How you know that?
slope at 8.
Because this is a straight line, and we know from geometry it goes down 1, over 1, down 1, over 1, down 1, over 1. Can you just count the blocks? Yes, you can. all over f of x squared. So what did you get?
93 over 4.
93 over 4. So someone in the last class conveniently, they did this one right, but conveniently just like dropped a negative sign in the process, but they had done all this stuff. Like they showed the f of x, h of x, g of x, all the x. Drop that one negative sign, that's a half point of an error, versus if it was just alphabet soup with nothing before, that'd be 3 or 4 points, it's the whole credit. Yes, Tim?
So could you write it as just L G prime minus G F prime over F squared, so like not just an X with it? Or is that wrong?
There are those that do. You should keep the x with it. And first period went through and created a piecewise function, and then said, well, just for this piece, the equation for f of x was negative x minus, or plus 10, I don't remember what the intercept was, and they put that here, which is subtle but technically wrong. Sorry, Jesse, just a second. Because that's true for that segment of the derivative, but not for the whole thing. Jesse, what's your question?
When we're like doing the finding h prime of x, we can just leave like the formula of the quotient rule. We don't have to plug in like 2x for g prime of x and x squared minus 3.
You can leave the alphabet soup. Yep.
Is there like a way to write f of x in this case that's not a piecewise function?
No,
Okay.
because it is a piecewise function.
Yeah, I was just a little confused.
Yeah, no. Nope, you're screwed, dude. So, what other weird beasties are there? So, do we need to check quotient rule again? Do we need to check power rule again? Sean?
Why not?
Why not? Well, because, okay, let me show you the other options. Glad you asked. So this is the posted quiz. Some people don't like to see the posted quiz. They want to do it themselves over the weekend. Just want you to see this is what was there. So given some information, can you graph what the function would be? Given the function, can you graph what the derivative would be? Piecewise functions, not your favorite. Here's a neat way of showing the derivative. You started with a piecewise function, you're out. It's not that bad. It's got like super frowny face. It's not that bad. The derivative of those three pieces. Okay, is it differentiable? Well, checking at 0, is it continuous? No. However, the slopes came in at the same height. So kids would skip testing continuity and go right to, yeah, the slopes are the same, all good. And at coordinate 3, the slopes were the same, so they're like, no discontinuities at all, differentiability everywhere. Nope, be careful. Have ways of making you take the bait. Product rule, power rule. Try number 7.
Is it just simplify?
It's do the derivative.
Oh.
Yes.
On the test, will you like make us find the derivative in a certain way, or can we do it?
You can find the derivative in any way you want now. I will not, like, it's rare for me to force you into something. Now that we are past the limit definition of derivative, go crazy. take me to, that's step one. So far, I see,
We knew that this year you were trying.
Wait, I split it up in a different way. So I did it as you do the project off. I mean, it's like got messy because it looks like you should be able to split here. You can't because it's x the negative 1/2 of here and x the 1/2 of here. So it's like not how it works.
I don't know. I've
No,
never-
you cannot.
I know, I think I'm gonna do it. I think I'm just gonna use the quotient.
so looking around, I didn't get to see everyone's paper. I saw a few people do the sleek, fast way. I saw several of you pounding rocks. So I did show this at least once, which granted, it's only once. Some classes I showed more than once. Divide and conquer before you try and do that complicated quotient rule. I can split the numerator up. And why did I write x squared as x to the 4/2? So that I could just easily subtract the exponents. All this stuff in red, haven't done a lick of calculus yet. Nothing. However, derivative of this now, super easy. Multiply by the power 2 times 1/2. Oh, that's 1. Lower the power from positive 1/2 to negative 1/2. The second one, that's tricky. What's the power on it? Negative 1. So multiply by negative 1. And then lower the power from negative 1 to negative 2. There's your derivative, all neat and clean. And those of you that are still doing the quotient rule, yeah. So, can we do the same thing with number 6? No. That one's, sorry. You gotta kick it old school and do that one. And more checking, do you understand things? Okay, not gonna do it yet, or maybe not at all. But this one, is there something I can do to simplify a little bit?
3,
What about the 3?
could you do 3 over gx times? No.
No?
3 over gx times f of x?
Can I take the whole stupid 3 out? And do that, and then do the 3 at the end? As long as you don't forget that it's there, that actually cleans things up a lot. That 3 being in the way, it's like a big old speed bump. Y'all get like tripped up by it. And then, hey, look at the velocity graph and then tell me stuff about it. So this asks, when is acceleration positive given this velocity graph? When?
Between 2 and 3 and 6 and 7,
Why?
because that's when the slope of the velocity graph is positive.
Okay. Emma, when's the particle moving to the right?
The right,
Uh-huh.
from 2 to 3 and
And then 5 to 6? Okay, this is a velocity graph.
Oh.
Were you reading it as position? Okay, so it's a velocity graph. Looking at the velocity graph, what's your answer now? When is it moving to the right?
Would it be moving to the right if velocity is
So when is that?
from 0 to
0 to 4 because the velocity is positive. But if you read this as position graph and try to answer things, you will get everything wrong. Please don't do that. We will all be sad. Okay. Try that. Volunteers? Lucas? We'll pick a color, I don't know.
Nice one finger.
Yep. Nice reuse. Oh, it pains me. It's backwards from the truth.
That's how I did it last year.
Oh, I'll get over it. That pains me.
Don't believe that.
Doesn't matter.
It doesn't, but it hurts me. I can still hear my calculus teacher. First time's the derivative is the second, and when you do it the other way, it hurts. This amuses Wilkie to no end. What the hell, man? Revel in my pain, you little sadist.
It is just
It
wrong.
smells wrong.
Like that's how I was thinking about it, and that's why I was like.
I agree with you. Hard part is knowing what the hell to do. Okay.
But in the it makes sense.
Did it the other way. First times the derivative of the second, plus second times the derivative of the first. It's not wrong to write it this way, it just hurts my head, thank you very much.
No, this is.
And then he's like, okay, there's the alphabet soup, yes, H prime of 1. Then looking up the numbers, which, honest, that is my shortcoming. Vision issues, flip numbers around. When I taught logic and an or, they flipped upside down, right, whatever. D, P, Q, they all the same letter to me. I have to look at it for a long time and be like, So I know myself, I'm comfortable with my shortcomings, and I know what I need to watch for. So, but yeah, we agree with the answer. Okay. What do you think? How you feel? Yeah.
We review differentiability and continuity problems.
Okay. What about them?
About them, just
Like,
nothing specific.
like that was the, okay. Like that. To be differentiable, does it have to be continuous?
Yeah.
Yes. If it's continuous, does it have to be differentiable?
No.
No. Okay, so to see if it's differentiable, first check, is it continuous? Where do we have to check that it's continuous?
At
At the two places that it broke.
the
So do that, check it. Are they continuous? Right, so you're giving it a look. What,
Well, I stress, part of it is not continuous. It's not fully continuous.
part of it is not continuous, how do you know?
Well, I plugged in 0 for the top one, which gives you 4, and then 0 for the part that would continue, and that's equal to 0.
Okay, so exactly what he said, I wrote down the work that he said. The limit from one side went to 4, the limit from the other side went to 0, to jump discontinuity, not continuous, so I can't do the derivative there. Okay, yes. Is that all we had to do for this problem?
So check the other discount.
Okay, is the other one continuous?
Yeah.
Knowing me, it should be, but also knowing me, typos happen. So the limit from the left of 3 and the function at 3 is 15. 3 from the right, 24 minus 9. Okay, it's continuous. Does that mean it's differentiable? No.
Not necessarily.
Not necessarily, but it might be. Okay, so that I don't hate you all Monday night, a nice way to write the derivative, how would we do that? Would we do spaghetti math all over the paper? Don't do, is there an Alex in here? No. So don't do like the Alex did. There were 4 parts to the question. A was down here, the work for B went like round, then over to here, and then he did part C, and then D went up and ended up in the middle. Oh my goodness. Alex and I did not always get along. Please work in a logical manner so that I don't hate you, and so you don't put me in a bad mood when grading. There are times when I just have to yell at the papers and then leave with the dog. And maybe I'll use your paper to pick up things. I don't. Wouldn't do that.
Can you just do the derivative of the parts that you need?
No. So right now, I didn't put equals on anybody. But no, you hear, do the complete thing. Don't be like minimalist and like seriously, you can't write 2 for x is less than, like, is that gonna kill you? Sweetheart? Ooh. Okay, so there's my derivative, written neatly, and I'm telling you where those derivatives apply, for which x values. I don't need to check the 0, it's already screwed. So, checking the derivative 3 from the left is 8. Checking the derivative 3 from the right is 8. They are equal. Just to piss you off, I'll put it on the other one, it doesn't matter. So it is differentiable at x equals 3. Why? Because it was continuous, and the slopes from both sides came in at the same steepness. So, yeah, what other kinds of things about differentiability? What kind of places can we not do the derivative at? Well, this, we can't do derivatives at discontinuities. What were you gonna say?
Vertical tangent.
Ooh, that's the hard one. vertical tangents, cusps, the birdies. Curvy corners. Oh, I just said the other one. Corners. And you guys have asked in the past, like, well, what if it's a straight thing and then, you know, it's a bird with a broken wing and then one brown? I don't care if you call it a corner or a cusp, it's just not differentiable there. Yeah,
It's really pointy, and it's also pointy when you zoom in.
yes, it's really,
You could say
doesn't
that.
have local linearity. Which that reminds me of another question that was on here. Okay, in the land of
You talk to me? Yeah, it is.
stuff. Okay, tricky questions. You know, like multiple choice, pot shot, I can just be like, knock these out. This tells you the derivative is this function. Okay, that's kind of weird. Which of these could be the graph of f? Are there things we can throw out right away? What? So anything that has a negative slope, because the slope is always positive. So anything that has a negative slope, wow, that was really effective. Yeah.
Anything that's, wait, never mind.
The last thing is Jesse?
For some am I crossing out, or which one is it?
Either one. Which one is?
I think it's D, because, you can't have a value of 2, because there would be a corner,
Okay, wait.
or in the absolute
The
value.
slope. This is the slope. The slope is the slope defined at 2.
Is that 0?
Can I plug 2 into the derivative?
No, because it's a corner.
No, you're doing the derivative of the.
So that's 0.
So f prime of 2 is 0. F, so the slope does exist at 2, which means the function needs to exist at 2. So it's this one. And the slope is positive the whole time.
But it has to be 0.
So Lucas helped us like narrow it down to 2. And then you gotta think about it. And Jesse, it's easy. Now that we're going back and forth between things, it's like, oh, it's gotta make it, yeah, it's gonna make a corner. The acceleration doesn't exist there. Or the double derivative. So, careful. What about this one? By greatest value, I mean largest positive number. Or largest number of the numbers. Is anybody I can throw out? William?
D.
D? Why D?
It's gonna be negative. And C, that's gonna be almost 0.
D to C, that's gonna be a negative number. Would you say what else?
C, you can also just throw that out on its own because it's gonna be almost 0.
F prime of C, the slope there is 0. Yeah?
Also f of a, because that's gonna be negative.
F of A is negative, so. Fourth period was kicked off with this. They were like, but this is limit definition of derivative. Like only if B is equal to A. So this is asking the slope from B to A. This one is asking the tangent at A. That's a super positive value. All right, guys, happy weekend. See you Monday.